Welcome back, dear children. Today we are going to start our new chapter, Probability. This is a very small chapter, children. This week we will finish this chapter. We have only one exercise and we have this chapter for our formative assessment. Okay? Now, what is probability, children? Probability means possibility. Okay, it is a branch of mathematics that deals with the occurrence of a random event. The value is expressed from 0 to 1. Probability has been introduced in mathematics to predict how likely events are to happen. Now suppose we toss a coin. Okay, what is the possibility of when we toss a coin? There are two possibilities. Either you will get a head or a tail. Okay, now tossing a coin is called as event. Tossing a coin is called as event. Now, what is the probability of getting a head? So, we will write probability of getting a head is equals to favorable outcome. Favorable outcome by total outcomes. Now, what is the favorable outcome? We have to get heads. How many heads we have? We have only one head. When we are tossing only one coin. Okay, when we toss a coin. We are talking about when we are tossing a coin. How many heads we can get? We can get one head. So, favorable outcome is 1. And what are the total outcomes? The total outcomes are either you get a head or you get a tail. So, it is 2. So, the probability of getting a head on tossing a coin is 1 by 2. Is that clear, children? So what is the possibility? What is the chance of getting heads? That is what we are going to learn in this chapter. The meaning of probability is basically the extent to which something is likely to happen. This is the basic probability theory, which is also called as the probability distribution. Okay, children, is that clear? Now, let's start our exercise. The first sum, a die has 6 faces numbered from 1 to 6. It is rolled and the number on the top face is noted. When this is treated as a random trial, there are 3 options. The first one, we have to find the answers to these 3 questions. A bit, what are the possible outcomes? B, are they equally likely? Why? And C, find the probability of a composite number turning up on the top face. Okay, children. Now, what is a random trial? We are doing exercise 14.1, page number 307. The first one. What is a random trial? The random trial is we are throwing a dice. You know what is a dice? We have it when we play Ludo. Yes, children, it will be cubical in shape. And we have numbers written on it 1 to 6. So we are going to throw that dice and we are going to see what are the possible outcomes. What will be the possible outcomes, children? So when we throw a dice, the possible outcomes will be you will either get a 1 or 2 or 3 or 4 or 5 or 6. These are the possible outcomes when you throw a dice. Yes, children? So therefore, number of outcomes is equals to 6. Okay. Now what is the second bit? Are they equally likely? Why? Now, are they equally likely? That means, do we have fair chance for all the numbers? So we will say yes, they are equally likely because when the dice is rolled for a large number of times, the probability of each outcome to occur becomes almost equal. See, 1 is appearing only once, 2 is also occurring only once, 3 is only once. If we have any number repeating more than once or many number of times, then we can say that the chances of we getting that number is more. But all the numbers are written only once, therefore the outcomes are equally likely. Are you getting it, children? Now the C bit. Find the probability of a composite number turning up on the top face. Now, what is the probability of we getting a composite number? First we have to find how many composite numbers we have from 1 to 6. Let us list them. The composite numbers are 1 is neither prime nor composite. Okay, 2 is a prime number, 3 is a prime number, 4 is composite number, 5 is a prime number, and 6 is a composite number. So there are two possible outcomes. Yes, number of possible outcomes is equals to 2. And what is the total number of outcomes? Total number of outcomes is equals to 6. So probability of getting the event as composite number. Probability of getting composite number on the top face is that the favorable outcome is 2 and total number of outcomes is 6. So favorable by total outcomes, that is equals to 2 by 6, which can also be written as 1 by 3. 2 ones are, 2 threes are. Express it in lowest terms, children. Okay, is that clear? Let's move on to the second sum now. A coin is tossed 100 times and the following outcomes are recorded. Head 45 times and tails 55 times from the experiment. A bit, compute the probability of each outcome, and B bit, find the sum of probabilities of all outcomes. Okay, children. Now the second one now. It is given that we are tossing a coin. And how many times we are tossing it? We are tossing it 100 times. So let us write a coin tossed 100 times. Okay. Now total number of heads. Number of heads that we got, that is equals to 45. 45 times we got heads and 55 times we got tails. Okay. Is that clear, children? Now the first bit. Find the probability of getting heads each outcome. So first outcome is heads. So probability of getting heads is favorable outcomes by total number of outcomes. Okay, so that is equals to, what is our favorable outcome? We want head. For the first one is probability of getting a head. How many heads we got? We got 45 times we got heads. And how many times we have tossed the coin? Total number of outcomes are 100. So it is 45 by 100. Let us strike them out using 5 table. 5 nines are, 5 twos are 0. So the probability of getting heads is 9 by 20. In the B bit, no, it's not B bit. We have one more probability of finding tail. For tails, it is 55 by 100. So that is nothing but 11 by 20. Is that clear, children? Now the B bit, B part is find the sum of probability of all outcomes. The sum of probabilities of all outcomes. How many outcomes are there? There are 2 outcomes. It is either probability of getting head or probability of getting a tail. So their sum will be 9 by 20 plus 11 by 20. The denominators are same. These are like fractions. So simply keeping the denominator as it is, simply add the numerators. 11 plus 9, 20. 20 by 20, that is equals to 1. The sum of probabilities of all outcomes will always be 1. Is that clear, children? Okay. Now complete your classwork and send me the pics of these 2 sums done neatly in your classwork. Okay. Thank you, children.